Yeah, correct. 0 to 8.
But you have to find the mass. You just need to find the average density.
No, you do. I'm just breaking it down. With the average density is going to be 1 over 8 times this. Yes, I'm just breaking it down a little bit. Right, exactly. So if you want to do the average density, sure. It's going to be 1 over 8 times what? The integral from 0 to 8 of what? 12 over. Yep. Yep. There it is. Yeah, and they're in your units, exactly. Now, on this one right here, can you anti-differentiate this? What do you think?
Use U substitution.
Yeah, will you use U substitution to do what?
To
anti-differentiate. So my question is this something we are able to anti-differentiate?
yes.
Yeah. What could you factor out to the front?
12.
So you have 3 over 2, the integral of from 0 to 8 of...
Wait, yes.
Yeah, you can factor it. Yeah, it's okay. I divided by 4. Yeah.
I did that.
X plus 1 to the negative 1/2 dx. And can you finish that?
Yes.
Yeah. We're not getting into huge depths with this, but there you go, right there. Evaluate. The integral of what? What did you try to...
1 to 6.
1 to 6 of h of r, right?
Yeah.
dr. But what do you put on the front?
1 over 6.
Yeah, exactly. There's your function average right there. So you have 1 over 5 times the integral from 1 to 6 of... And what can you factor out to the front? A 3?
Yeah.
And it's going to be 1 plus r to the what? Negative 2 dr. We can anti-differentiate that and end up with 1 plus r to the what power? Negative 1, yeah. But what do we need to pop out front, Andrew?
1.
That one, I'm sorry. Yeah, we have to pop what out front?
You have to 1 over -2. No. Negative 1.
Negative 1. We just make it negative, right? And what are we integrating from and to? Andrew, we're doing the question you wanted to do, so let's pay attention to it. 1 to 6, exactly. So does that match what you have?
Yeah.
So it's just evaluating it, which was a little tricky?
I think it might just be a calculator problem.
Ah, calculator problem, exactly. Okay. What's the integral going to be, McFall? 1 over?
1 over pi.
Minus 0, yep.
Yeah.
From?
0 to pi.
Yep.
Cosine to the 4th x.
So cosine x, I'm going to 4th sine x dx. Now, what should you be using now?
U substitution.
So u is equal to? What do you think? Cosine x. So du is equal to cosine... what am I doing?
Negative sine x.
Negative sine x dx.
Yes.
So dx is equal to du over? So now we plug in, and what do we end up with? 1 over pi integral from what to what? What's cosine of 0?
Oh, it's negative 1 to 1.
What's cosine of 0?
1.
1. What's cosine of pi?
Negative
1 to negative 1
Oh,
of
that's where my mistake was.
u to the
U to the
4th
4th.
sine x, but then what gets dropped in here, which is that nice magical step. That's gone, right?
Yeah.
And if it makes you feel better, you can get rid of the negative and then flip the limits of integration, right? So it becomes 1 over pi times negative 1 to 1 of u to the 4th du. Because we flipped the limits of integration and canceled it with that negative right there. Because when you flip, it makes it negative. And we factor out a negative. Negative times a negative is a... It is a lot of negatives. You're right. It is a lot of negatives. If you wanted to, you could say this is equal to 1 over... This is equal to... I'll tell you what you could do. This is equal to 2 over pi times the integral from 0 to 1 of u to the 4th du. You can double it, double half of it because it's an even function.
Yeah.
And that you're going to get the same thing. This can be really helpful sometimes because sometimes you have to plug in a value into a nasty function. What's easier to plug in than any number, generally speaking?
0.
0 is great to plug into things, right?
Just cancel stuff out.
It can't, a lot of things. The explanation behind that is, you okay there? Let's say we had an even function where it does the same thing on each side of the axes, like this. And let's say I went from negative a all the way to a. What you know, because it's an even function, is that area right there is the exact same as this area right there. So what you can do instead of going from negative a to a, you can go from 0 to a twice. So you just do double 0 to a. Because
Odd, you know it's 0.
when it's odd and goes from negative a to a, it's 0. Correct. Because if it's odd, instead of going over like this, what's it going to do? It's going to go down, and then this is going to be the opposite of the green area. It's going to be the opposite. It'll cancel out. which is really helpful. The reason they present it in the section on use substitution is because you get this tool which you think you can use all over the place, but then you get something like this. I mean, you get like -1 to 1 of sine x over 1 plus x squared dx, and you look at it and you're like, man, that kind of looks like tangent inverse, right? Or something with tangent inverse, and I can totally do that one. And then you try all these different use substitutions, and what happens? You can't. It just don't work for you, right? The reason they add this in is because you get this tool that you think can work all the time, and it doesn't. You need to recognize that's an odd function, so what can you do? Oh, it's 0.
Just recognize the -1 to 1.
Yeah, you need to. That should be a warning sign. The warning sign should always be if you get a symmetric negative a to a, think to yourself, is this odd or even? Ooh. Now, what's the side note on this is we know that the area of this integral is, the value of this integral is 0. But do we have any idea of what it is from 0 to 1?
So how
Hold on, answer my question. We know that because that's an odd function, you're going from negative a to a, the integral is going to be 0. The side note to this is, do we have any idea what the integral is from 0 to 1?
No.
No, we don't care. We don't want to know. We don't want to know. Just to review that,
Oh, you do the f
if f of negative x is equal to negative f of x, it's a odd function. And if f of negative x equals f of x, then it's a even function. Is it now, it's kind of a bad labeling system because it's possible if a function isn't odd, does it mean it's even? No. A function can be even, odd, or neither, but you usually think of even and odd as integers. And integers are either odd or even, or like real numbers are rational or irrational. You have an odd and even function, but it also could be neither. It's just poor labeling. What?
3.
And what's the upper bound?
0.
What's the lower bound?
13.
Yeah. Dx. There it is. The upper bound in this case is 0. Yeah, so draw it. You can do it. You got it. Let's graph this. So this one's going to be concave down and has intercepts at plus or minus root 20. And this one's intercepts at plus or minus what? Root 12. So you kind of have to estimate these things. And this is going to be down, and this one's going to be up. So you, well, we're going to do that eventually. That's correct. Find the intercepts. That's fine. This one right here, it's symmetric over the y-axis, and it hits at what when x is 0, it's at what, 20? Right? I know. This is at 20, and the other one's going to be at negative what? Crosses the y-axis at negative.
12.
I'm just trying to negative 12. So this one's going to be up, and this one's going to be down like that, and it goes. It's a little steeper than that, isn't it? Something like that. It is supposed to be symmetric, right?
Yeah.
Not doing a very good job on that sketch.
Yeah.
It looks perfect. Thank you. Thank you. So you have to find the intercepts.
Yes.
So 20 minus x squared is equal to.
X squared minus 12.
So you have 32 is equal to x plus or minus 4. So what's our integral? Negative 4 to 4 of the upper one, which is 20 minus x squared minus dx. You are absolutely correct. Yeah, nice. So can you finish that theoretically?
From multiply if I take it from 0 to 4.
You want to go from 0 to 4 and double it?
Yeah, because it's
You can do that. So you could say, if you wanted to, this is going to be 2 times negative 4 to 4 of.
Nope,
The whole payoff was that 0. Thank you. Of. You can do it out here. Negative 2x squared plus what? 8. No, 32.
32.
I can almost do basic math today. Almost. And then you can factor out a negative 2, right? I hear consternation. Are we okay? Negative x squared minus x squared is negative 2x squared.
Yeah,
20 plus 12.
Yeah.
So end up with negative 4 from 0 to 4 of x squared minus
Minus 32.
minus
That would explain things. It's
16.
like, how am I getting
Yeah.
a negative answer?
Nice. So is that the nicest way to do it? Yeah, I think it's the nicest way. So what's a good first step?
Drawing the picture.
Drawing the picture, exactly. So let's draw the picture. I did. So Brad, let's watch for a sec. 2x. There it is. And then x squared Goes up like that, and that's a terrible parabola, isn't it? It's not bad. And then how does it spinning around the x-axis? So it's going to go down like that. And then what's this going to do? It's going to go like that. So what kind of shape would you want to use, or do you want to use?
I would actually say
You want to use washers? That's fine. Okay, so we need to find our intersection point. How do we find the intersection point? So x is going to be equal to 2 or 0. So we're looking at pi times the integral from 0 to 2 of what?
2x minus
2x
2x squared.
squared
Oh.
minus what?
There's my mistake.
X squared squared dx. You have to square each one. You have to square each one. Yes.
That's what
Each
I
one.
knew that.
Look, you know that. Well, yeah, because the slice here, what's the slice look like? You didn't square it? So let me guess, you forgot.
No, we squared it at the wrong time.
Oh, you squared it on the outside?
Yeah.
Yeah, you don't square the outside, you gotta square the inside. Yeah. So, you make a sketch first, right? It's only a little bit more difficult. It's a sideways parabola, starts at 1, like this. And then you've got the y equals x minus 3. Just kind of cuts it off, right? Where did that look like? Yeah, there we go. Looks like this.
Well, that would have been nice.
There it is. So you're taking this right here, this shape, and what are you doing with it? You're rotating it around the, what are you rotating it around?
Long.
Y-axis. Nice. So what do you want to set up? Do you want to set up, what's the easiest way to do this? Washers or shells in terms of X or in terms of Y? Washers in terms of Y, yeah. Because you want to take this as your slice right here.
Yeah, no, so it involves fewer.
So you need to find out where they intersect, right there and right there. Anybody know what the lower bound was? Anybody get it?
-1 to 2.
-1 to 2. Do people agree with that?
Yeah.
-1 to 2.
Is that
It's probably not
talking
a
about the
mistake
y
later
value?
on.
The Y value, that's correct, yeah. dy, and it's going to be pi on the outside.
You have the right answer.
Am I okay so far?
Yes.
Yes.
Am I okay? Kids, take a look.
Yes.
So then this needs to be just in terms of what?
Y.
So it's going to be, is it, oh, that's not a Y. So x equals what?
Y plus 3
X equals y plus 3. So we have y plus 3 quantity what?
squared.
Ah, there we go. Minus what? What did you get? 1 plus y squared. Because it's already isolated. 1 plus y squared. There it is. Now, you need to evaluate that, and what should it evaluate to? 117 pi over 5. The setup is what you need to get good at. The setup.